Okay, so we're going to wrap up this. Again, we're in part one. There's so much to this story, but we're in part one of section 3.1. And one of the last things we need to consider is how do I find domain just given a function, right? So I have a bunch of functions down here. How do I find out what values of x I can put in? And so it turns out that what we can do is use what I playfully call red flags. So this way we don't even need a graph to visualize it. I can just look for red flags. Now to find those red flags, let's kind of think what math conditions cause something undefined or unreal to happen in our class. And we've actually seen both of them. All right, and so one of our red flags, if you want to call it red flag number one, is division by zero. Right? Division by zero, if I take, let's say, 5 and divide it by 0, this is undefined. And so in relation to domain, right, remember domain, those are the inputs that I put into the function that create an output. So if I'm putting something into the function that creates a division by 0, that's a problem, right? Undefined is not a valid output. So we're going to try to avoid division by 0 situations. And then the other one, the unreal one, is what happens when we take the square root of a negative number, right? We know that that creates an I situation. So red flag number 2, if you would, is we need to make sure whatever inside, right, the radicand has to be positive. So that expression, right, has to be bigger than or equal to 0. Okay, and so those are basically the things that we're going to be looking for. And the cool thing about it is if your function doesn't have red flag number 1 or red flag number 2, you can automatically assume that your domain's everything. All right, no red flags, right? The domain is everything. If you have red flags, you have to account for it, and I'll show you how we're going to do that. So that is basically how we find domain without a graph or without a pretty picture, without our graphing calculators for that matter. So looking at the first one, right, we have a nice linear function. So again, I think you guys know, right, that this has -3 and then a slope of 2. So just visually looking at, we can see that it goes on forever and ever. So all x values are going to create it. So I'm kind of using a graph there. But using what I told you, there's no red flags, right? The denominator is always equal to 1, right? So there's no division by 0. And I don't see any square roots. So no square roots, no division by 0, so no red flags. So what's the domain? Well, in this case, we're going to use interval notation, right? We're talking all values from -infinity all the way up to +infinity and everybody in between. So all the nice numbers, the hard numbers, the decimals, the fractions, the integers, everybody works. That's what that interval notation is telling us, as opposed to the discrete notation. Everybody works. B, all right, g of x equals x squared minus 2x minus 8. Well, again, thinking of red flags, right, this is always over 1. So no division by 0. And I see a square, but I don't see a square root, right? It's the square root that's the problem. So I don't see any red flags. So what does that mean the domain is? Everybody works. You can put whatever you want in here and always get an output of y. So everybody's going to work. Last but not least, C, we have an absolute value function, right? That's what the h of x is. Again, absolute values create its own situation, but this technically is all over 1. So no red flag number 1, no division by 0. And I see an absolute value, but I don't see any radicals. So that basically tells me, again, we have no red flags. And so my domain is a very strong one, from -infinity to infinity. So that is how we can start to find, what values of x, right? What inputs can I put into the function and get an output for? Well, these 3 functions are very strong. You could put whatever you want. Nice numbers, crazy decimal numbers, rational numbers, irrational numbers. It doesn't matter. The domain's everything, -infinity to infinity. Okay, let me do one more round and then I'll stop and I'll cut another video for the next ones. But here, right, when we look at D, f of x is defined to be 3 divided by x plus 1. The good news is I don't see any square roots, so that red flag we don't have to consider. But we do have to consider, when does the bottom equal to 0? So we're trying to avoid, right, we do not want that denominator to be 0. Subtracting 1, this means that we don't want x, right, to be negative 1. So we can say it this way. We can say all x not equal to negative 1, right? But what I eventually want you guys to do is learn your interval notation. So I'm going to draw a picture of this so we can see the intervals, right? So there's 0, here's negative 1, negative 2. So we're not including negative 1. And we're including everything to its left, and we're including everything to its right. The only value that we cannot use in our domain is negative 1. That's the one value that causes the division by 0 problem. So what's my interval? Well, on this side, right, we're bounded by negative infinity up to negative 1, right, using parentheses. On the other side, right, we'll probably use a union there. We're from negative 1 to infinity. So negative 1, I'm using parentheses to show that we're throwing negative 1 out, and we're going to negative infinity in that interval, and we're going up to positive infinity in that interval. So there would be your domain. It consists of two interval notation values, things to the left of negative 1 and things to the right. Hopefully that picture kind of helps you see the left to rightness in your interval notation. Letter E, let me put a little marker there. Again, there's no square roots, so we don't have to worry about that red flag, but we do in fact have a problem with the division by 0. When, right, we have to figure out when does the bottom, I don't want it to be 0. So adding 16 to both sides, I don't want x squared equals 16. Applying a square root using my square root property, we find that there's actually two values that we can't be equal to. So our domain is all x not equal to negative or positive 4. But again, getting prepared for an interval notation, here's negative 4 and 4 on my number line, and we're throwing those out, right? They're going to have nice open circles on them. So we're in this interval here, we're in the interval in between, and then we're in that interval there. So the domain, if we describe that interval, that's negative infinity to negative 4. Union, we're talking about negative 4 to 4, right? That's that interval. And then union, we're talking about 4 to infinity. So there would be the interval notation. Here would be the graph. And here would be the way that I could describe the domain. So in words, we're talking about all x values not equal to plus or minus 4. Visually, we're talking about the interval to the left of negative 4. We're talking about the interval between negative 4 and 4. And we're talking about everything to the right of 4. And then, of course, interval notation, where I want everybody to be, we're talking about those guys there. Okay, so there's how we find domain, right, without a picture. We basically look at the red flags, we account for those red flags, and essentially, in this case, start throwing some things out. So last but not least, again, there's no square root, so we don't have to worry about that red flag, but we do have to worry about when does the denominator equal 0. So doing a little factoring, let's see if I can factor this thing right. I believe that'll do the trick. All right, so we get 2x plus 3 can't be 0, or x minus 2 can't equal 0. Adding 2 to both sides, we get that x cannot equal positive 2. Subtracting 3 and doing a division, we get that x can't equal negative 3 halves. All right, so again on a number line, negative 3 halves is somewhere over here, 2 is somewhere over here, and we're throwing them out. So we're either talking about all x not equal to negative 3 over 2 or 2, or we're talking about everything in that interval, everything between them, and everything in that interval. So we'd have negative infinity to negative 3 halves, union, negative 3 halves to 2, union, 2 to infinity. Sorry, I was running out of room there. So that interval notation describes that interval, this interval notation describes that interval, and that one describes that one. So we have the interval notation, we have a graph on a number line representing the domain, or we can visually just say all, or verbally say all x values not equal to negative 3 and to positive 2. So there's that. We use our red flags. We're almost 10 minutes into this, and I have 6 more to do. So I'm going to do that in a new video. All right, I'll see you guys then.